Welcome to Aspire's Data Streams, Episode 1, where we're having a conversation with Bryan Duncan. Bryan, introduce yourself.
Sure, thanks for that. I appreciate it. My name is Bryan Duncan. I've been a pre-sales engineer for the better of the last 15 years. I was a solutions architect, an admin. I've worked for healthcare. I've worked for litigation support companies. I've ran a lot across the gamut. From a pre-sales perspective, I worked for companies like EMC, Fusion IO, Coho Data, Teradata, HPE, etc. And today I'm working for Tintri, where we're helping solve customers' challenges around virtual machine workloads.
Excellent. And you're perfect for today's guest. Today, we're going to tackle storage from our previous cast that you have watched. We're looking at modernizing data center and what that means to actually realizing cloud resources or cloud benefits. So, Bryan, I think taking a step back, right? I really like to look at going back to see where we were and what data center modernization looks like today. I know as a pre-sales architect or somebody who worked with storage a lot, building back end clouds, working in the cloud industry. Storage back in the day, I remember, right, was typically about the drives. We had mixed kinds of drives, SSD. At least when I was coming in, right, was kind of very expensive, but you needed some of it, but you couldn't afford all of it. It was very costly at that time. So I do remember those days when we were looking at performance, and if you needed to get to a certain amount of IOPS, we had to build big systems, right, to get to some performance that at least would the application would be able to run the way it was expected, right? I know you'd mentioned you came from that background. There was some EMC, I think, that I heard in there as well. Um, Give us a little snippet of what you saw back in those days.
Sure. Like everything in this world, everything's cyclic, right? So we started with punch cards, then we went from to reel tape. Then we had disk drives, right? Um, if you remember the old kind of mainframe solutions, there was a whole building just for CPU, a whole building just
Oh,
for networking and back end, right? FICON. And then you had a whole nother building which was just tape and disk, right? I may look young, but I'm up there in age, and my father was an engineer coming up in the '80s through the ITT Burroughs, mainframe days. So I do remember the 50 megabyte giant pizza oven discs from back in the '80s. I was probably about 4 or 5 years old, running the cables underneath the floors at some of these large New York customers. So yeah, I've been there, right? So what we've seen change is, we had traditional spinning disk drives, and that was fine. We had what SCSI at the time, and then we introduced fiber channel drives, right? Then we had SATA drives. So you're seeing the change, and it's an evolution, right? You're going from I need performance to I need capacity to now I need capacity and performance.
right.
And you're seeing the technology in the back end change and adopt to that, right? You have this thing called Moore's Law, right? Moore's Law is typically a CPU conversation, but it applies to disk drives. What it says is, basically every year, the capacity is going to double, right? It's going to get denser, it's going to get much faster, but it's also going to get cheaper, right? And then you apply that to the technology curve, which shows, as things are introduced, right? Nobody's using them, so they're quite cheap or inexpensive to purchase or start using. And as they get popular, right, the price goes up. And then as that technology gets a little bit older and the next version comes out, right, that first version becomes much cheaper as the new capacities and models are available. So what we're seeing here now is a shift, right? So I don't know any customers that are still using traditional spinning disk, right? Everybody has either moved to a hybrid storage array. By hybrid, I mean flash and spinning disk, or a complete SSD only solution, right? Here at Tintri, our new solutions are providing NVMe storage. NVMe is more in line with what we sold at Fusion IO about 6, 7, 8 years ago.
Hmm.
They actually pioneered that NAND flash, right? So a PCI based flash card. The difference there is with this latest technology is it doesn't need a RAID controller, right? If you're putting it inside a server and it's a physical server, let's say, that PCI card being local to that bus of the CPU, it could communicate directly, right? So there's no more RAID controllers stopping the I/O path. So things are going to process much faster, right? In the late 90s, if you saw a CPU running at 90%, 95%, you bought another box because something was wrong. These days with virtual machines, VMware, containers, cloud-based workloads, right? We want that to run at 97, 98% because we know that CPU is actually working, right? And if that CPU is working, then we won't have things like disk queuing, right? Disk queuing is
Right.
where the disk and the network could keep up with the asks, but the CPU is now the bottleneck, right? So what I've seen is now the disk is extremely fast. The networks are extremely fast, right? We've moved away from fiber channel. We've moved away from iSCSI. We're now using things like NFS. Why? It's much easier to use. One person can manage petabytes of data instead of using or needing or requiring an entire team for disk, an entire team for WWN and SAN zoning, right? It's just one team now, a much smaller team that's trying to do the same workload that maybe two or three times the size of that team was maybe 10 years ago, right?
Yeah.
So we're seeing things become easier. We're seeing a lot of automation being built into these products, right? Essentially, these new storage products are extremely smart, right? So they're capturing information from the network, from the actual servers themselves, and a lot of these new storage arrays can make intelligent decisions on, say, what path to send this data down, right?
Yeah.
Or, what tier should I store this data in, right? I can tell you from my days at EMC, there was a metric that about 80 or 85% of your data has been touched in 90 days. I'm not sure if that's still accurate, as most people are archiving to clouds. And why not? They have kind of a tiered approach.
Hmm.
But if you have everything in one bucket or one LUN, and you're having challenges for a backup window or snapshots or DR, number one is remove that old data from the environment, right? Put that in a cloud bucket on S3 perhaps, or some really cheap, inexpensive disk, and remove that from not only production but your backup windows as well.
Well, so what I've been seeing, just to kind of how things progress, right? You talked about the older style spinning discs and what we were doing back then. From what I see that has changed was the fact that we're now controller based when it comes to performance, right? So now we have controller based storage that gives us the ability to either increase, decrease the performance at the controller level, and then the disk really is just a subsystem to put your data on top of. And then the controllers now become the intelligent piece
Yep.
of storage. And it adds a lot of different layers to it. You were mentioning, different things of tiering. Uh, where do I put my data? So all of that is being done at that level, and that also provides easy upgrades, right? I think the old days of having to do lift and shift are becoming things of the past. Controller based, if you're in the same footprint, it's a controller based upgrade. So we're seeing a lot of that in industry. But one of the things that is also bringing into it is a lot of visibility, right? I think the management aspect of storage has become key, and I think that's in any technology, right? Where server technology, we talked about that previously in another video cast, where server technology and all these other technologies are looking for a way to manage data, and as data passes through it, and then ultimately giving you visibility, right? Because a lot of the tooling back in the day was things that you put together, scripts or whatever, right? Or you had to purchase tooling that was available from the vendor but didn't come with the solution. Now we're seeing that all baked in, and it's all done at the controller level, right? So, um, what have you seen with the controller aspect? How have we gained ground with that from what you've seen?
Yeah, good question. Let's take a walk down memory lane 10, 15 years ago, right? You're probably buying a NetApp array or an EMC array or Hitachi, right? The IBM, right? Those big,
Hmm.
big player names. And what did you buy, right? You bought a controller or dual controllers, right? So you had two active, two passive for standby. What we're now seeing is that the controller itself is housing the capacity, right? The problem with that old architecture um, is you only had a fixed amount of CPU in that controller. You only had a fixed amount of memory. You only had so many network ports for pushing IOPS, right, or bandwidth and throughput across the network. But we kept adding shelves of disk to the back end of that controller, right? Every year, another, what, 25, 50, 100 terabytes. And we're adding that behind the same controller, right? So we did that for a very long time. We were using fiber channel, right? Then we started using things like InfiniBand. Now with NFS over 100 gig networks, y- and the lower cost for controllers, it's a paradigm shift, right? It's a different way of looking at things.
Hmm.
So instead of buying a single controller or a dual controller and daisy changing disk shelves behind it, um, controllers are lower in cost today. So a lot of companies, Tintri, are asking our customers to just purchase a controller. We put the disks locally into that controller, so the I/O path is extremely short. And when we fill out or max out capacity, because it's a lower cost than the traditional approaches, you could just purchase another array. And what that does is that doubles, right, the amount of CPU you have. That doubles the amount of DRAM. That doubles the amount of throughput from the network perspective, right? One of the benefits of Tintri is we have a global management virtual machine. We call it Tintri Global Center. And that one virtual machine can manage uh, 60, 70 individual arrays, petabytes in size. So you still get that single management dashboard across multiple different pieces of hardware.
Yeah, and that's key, right? As I mentioned earlier, um, we're now looking at managing across multiple stacks, right? Whether it's multiple locations, obviously cloud hybrid comes into play as well. And one of the things that I do want to kind of touch upon is ultimately the reason why we build these systems or why infrastructure is built today, and what sits on top of it, and what actually realizes the benefits of what's being put in right underneath. And that's the application. A lot of I mean, applications are driving this infrastructure. They're driving the hybrid world. They're driving large data sets today. Everything's consumed. Video is huge. So these applications now are following this modernization, or at least pushing this modernization, right? Because we need to do more at the application level, which then begets the need of having faster performance. But the key piece is to understanding performance through visibility. So understanding where are your pitfalls, where are your bottlenecks. That's from any layer of infrastructure. And I mean, containerization is huge today, and that's just being spread across everywhere, which is ultimately, again, moving to cloud in a hybrid situation. Storage today for applications and containerization. Can you touch upon that real quick? What you're doing today?
Yeah, absolutely. Well, first off, right, just to kind of circle back, it's all about automation today, right? That's kind of the theme. Digital transformation. It's all about how can I get more out of what I have today, right? That's really what it comes down to. Um, if I can look at my past customer history, maybe I know what to put on sale that week because the data tells me to, right?
Right.
Um, when I look at my historic data, if I'm a sales company, right, retail, I know when to mark that down. I know when to send out those emails. I know when to send out a coupon because the data tells me, right? From a financial services perspective, when we look at data, right, that's going to tell me whether or not I could get that mortgage approved or that bank loan, etc. Right?
Hmm.
It's all about data today. So the conversation is for us, it's storage, right? So, how can we automate storage by looking at data that's already out there, right? So, one of the benefits of Tintri is that our developers were very close. Some of them actually worked for VMware when they were writing the code for ESX
Oh,
3.5 and vSphere 4. So, our code, our solution, the Tintri VM Store, actually monitors everything that vCenter is spitting out, right? So all the data points from the virtual machines, the applications, the workload, that's all being captured by Tintri, and our AI and algorithms allow us to move resources based on the needs of the workload. Versus, yesterday that was a whole manual process, right? I
Right.
was
Yeah.
looking at perfmon for a week or two at a time, right? I'm doing back of the napkin math. How many drives do I need for 60,000 IOPS at its 98% peak times? And I have to buy all that for only 2 times a year, right? Being retail, for example, maybe it's Mother's Day or Christmas, right? My two busiest days, but I have to purchase 3x my infrastructure to keep up with those demands. That's where cloud comes in, right? Cloud adds a lot of value for elasticity. I could spin up, I could spin down as required. For media-based companies, the cloud is extremely important, right? Netflix, those type of folks, they have edge nodes, they're caching. It serves your customers their data much faster, right? Or
Mhm.
they, whatever they're purchasing, right? With Netflix, I'm subscribing to a movie, I want that immediately. Cloud adds tremendous benefits there, right? What I have seen from my experience is that not all workloads are meant for the cloud. Uh, a lot of
Agreed.
a lot of companies went all in on, let's say, AWS. And what they found out was things like latency will actually destroy productivity. So you have to understand your data as well, right? So certain workloads will remain on-prem because it's just easier, right? Can you make it work in the cloud? Sure. You could throw money at everything and anything and spend a lot of time and kind of make it work over time.
Yeah.
Um, but what we've seen is a lot of customers are putting archive data to the cloud. They're doing analytics, really high frequency, low latency type application that remains on prem. um, Anything around stock, or trading, right? That's remaining on prem as well. But things like the IT, you know, annual barbecue, that doesn't need to remain on prem, right? We can move that to an S3 bucket in AWS or Azure,
Right.
snap it, remove it from the backup stream, right? And that helps you keep your workload smaller. It helps keep your team smaller, right? It keeps costs lower.
Right, right, and I think that's where I was headed. Right, the workloads are driving where things should reside today. Is it on prem? Does this application make sense to be moved out to like one of the hyperscalers, or does it make sense to keep on prem? But a lot of that storage today that's being consumed by these applications, are stretching across multiple locations. And as we talked earlier, is the management aspect of now you have data in multiple locations. We got to manage it in multiple locations, look at performance in multiple locations, and the teams, although they've become smaller, they're becoming broader, right? So the knowledge base of an admin today, which used to be local, has now to expand to a hyperscaler, or maybe you're consuming other VMware-based cloud systems out there, um, that has other different workloads, right? That makes more sense. And it's all, again, there's a costing aspect to it, right? We need to make sure that as we're building out these hybrid models, the costs are beneficial to the organization. And ultimately, that's where I think this conversation comes into play, where we're talking data center modernization, because we have to understand how things run locally, what are the benefits locally, what is the performance, because ultimately we need to translate that. If we have a cloud mindset, right, if we have a cloud initiative, I should say, and we're looking at a hyperscaler or something, whether it's just archiving or not, we have to understand how it works locally and performs, so then we can then translate that in hybrid, because we need some type of standard. And I think, looking back, modernization is about creating a standard for your applications and your workloads and how they should run, right? And then ultimately, you need to take that standard and translate that out to cloud. And that's kind of what I've been, when I put things together. I make sure that things are performant, and all who's going to be your consumer, and how are they going to make more noise, meaning if I have users that are using my application, they're going to be the alerting mechanism. Hopefully not. Hopefully we have some better monitoring for that. But ultimately they're the ones who will complain and bring that forward, and that could be lost revenue, could be brand recognition that gets damaged,
Of
and then
course.
that's really what hurts, right? From a
Of
business
course.
perspective, that's what we're looking for, right? But driving it back down to the storage aspect of it, key performance metrics, I think, is valuable to building the modernization piece, and you had touched upon it earlier, where Tintri does provide those mechanisms for you, right, in the hybrid cloud. So in this hybrid cloud world, understanding the performance metrics, what have you seen? I mean, are there other tools that we can leverage? I know you mentioned automation. APIs are huge, right? I mean, having visibility. So,
Yeah.
managing this through APIs, are we building tools? What kind of tools do you have, or have you seen that somebody could leverage to look at this multi-cloud aspect and manage all this from one location?
Yeah, it's a great question. It's very broad stroke. So I'll take my best to answer that. Right. So
I gave you some.
number one,
I gave you some room.
appreciate that. What I would say is that containers are becoming the norm these days. Right. So
Right.
as I said in my earlier conversation, the mainframes had separate buildings for each piece, right? Compute, network, storage were all separate buildings. Then we had x86 servers where we put everything into one 2U or 1U appliance, right? A pizza box. Then we went to virtualization where we were able to run multiple operating systems on one piece of hardware, right? And it was kind of elastic. We could move it around, right? But we needed to have similar hardware at the locations for it to be able to move to. Now with containers, containers gives us the ability to really move that around to unalike hardware or even unalike public clouds, right? So number one, I'd say definitely start looking into Docker, Kubernetes, right? Rancher is a free tool. You could start to play with it, get some workloads going. Um, the larger companies that are out there today, all their development is done through containers, through a CI/CD pipeline, right? Um, if you look at the AI and ML, machine learning type of companies that are out there, and it's being done everywhere, right? We have machine learning. Our parent company, DDN, that's where they focus. Every oil and gas, right? Every airplane, every flight, right? One airplane flight, if you didn't know, that could create 10 petabytes of data. One flight across the
Wow,
coast.
I did not know that.
Yeah, it's insane, right? So, people like the engines Rolls-Royce, for example, use machine learning and AI that if they hear with sensors that they hear the engine noise change in frequency, they know from the modeling that a part's going to go bad in X amount of days or hours, right? So it's a safety feature, right? Technology is assisting in being more safe. From an IT, brick and data um, perspective, right? Virtualization is adding a lot of value. APIs, obviously great, right? I don't have to just use Fiber Channel. I don't have to just use Block, right?
Hmm.
Or File. Like I have um, this way, or I have this translator that could assist me. One thing you do got to be very aware of though when you go into a cloud is the egress ingress costs, right? Everybody says it's going to be easier to use. It's really not always easier. They say it's going to be cheaper. That may be true for years 1 through 3. But what I've seen is once you get to year 5, year 7, you're actually paying almost 2 to 3, some cases 5 times more than you would if you were to keep it on prem. And then you introduce the challenge of latency, right? So if you're trying to do something that's analytic based, right, or some type of BI workload, or anything around big data, right? I know that term's kind of vague now, but anything around that, from a cloud perspective, your issues are going to be concurrent connections, right?
Hmm.
Um, if you have 10 or 15 analysts and 2 data scientists trying to work against that data, um, I can almost guarantee you're going to run into problems from what I've seen, right? There would have to be a slim, very small configuration that would work straight out of the gate. Um, you'd have to be on at least a 1 gig connection from home, right? To kind of like make that happen.
Hmm.
Everything within that path would have to be uh, at the upper end of things for to not suffer any type of latency challenges or bandwidth challenges.
Wow, yeah, and I think you hit it right, right? and I mentioned this earlier, and I just want to touch on this again as we kind of come to a close here, is the fact of we talked about performance, we talked about how things run, we talked about cost implications inside of cloud, specifically with storage, and all of those really wind down to not really understanding what applications should be in cloud, what applications should stay on prem, and that understanding actually comes through um, looking at your
Yeah.
current state of applications or performance or infrastructure, understanding how it's performing today to build a standard that we can ultimately actually move and build out. I think you we had this you had mentioned earlier where people were running to the cloud and then people were running away from the cloud because of the cost implications, and it was literally somebody just trying to forklift what they had because it was a cloud initiative they needed to run to the cloud. That was an initiative that may have been come down from the top, and then ultimately when you're just trying to take what's a mess internally, you move that mess and it's going to be a costly mess. So, this is great. We're having this conversation around data center modernization. And I think that's key when looking to build out to a hybrid situation, specifically around storage. We need to understand what our storage capacities are in real time, performance in real time. Once we understand that, we build a standard and then are able then to model out into hybrid cloud or whatever other storage that we're looking out in the cloud. But I do appreciate this conversation. I think there was a lot of good things that we hit on top of. Thanks again, Bryan, for joining us for this episode of Data Streams, and we look forward to having another conversation with you again. Thanks a lot.
Thank you very much. I appreciate it.